I just X this out. It's already
No, you
done.
may not. Okay, let's talk about yesterday, what we learned. This is a refresher. You should have your scrap paper in front of you too, okay? Chromebooks beside your chair. All you need on your desk is your paper and scrap paper. Your workbook page and scrap paper. Okay, hurry up, get that paper out. Yep. Come on.
One piece of paper.
Now put your binder beside your chair, like I taught you. And your Chromebook beside your chair, like I taught you.
No, it's just one. That's one more that.
Okay, so this is what I told you yesterday. We use this as an example, okay? We called this number right here the exponent. Do you remember that? Look on your notes real quick. It should say that. That number was the exponent, and we drew an arrow down here. What did that arrow tell us? The number what? Of zeros in the answer. So if you see a 6 up here, then you know in the answer there's going to have at least 6 zeros. How do we say this number? 10 to the, what did we say?
6 power.
Good job. 10 to the 6th power. So let's start here on number 17, okay? Get your pencils ready, and we're going to have to write some things on our scrap paper again. One box of printer paper has 3 times, say this number with me, 10 to the 2nd power sheets of paper. Well, that doesn't really tell us how many sheets of paper it is, so we're going to have to turn this into a real number. So let's just start with 10 to the 2nd power. 10 to the 2nd power would be a 1 with how many zeros on the end? Say it, 2. So mark that out and put a 1 with 2 zeros on top of that. 10 to the 2nd power is 100, but we're not finished. Because that's really not just 100. It's 100 what? What? Times 3. So Bentley, what's 100 times 3? 300. So mark all this out. And now put 300, just like that. So now how many sheets of paper are in that box? 300 sheets of paper. That makes more sense than 3 times 10 to the 2nd power. Eric, did you write that? Okay. Now we're on this word another. Get your pencil on the word another. Get your pencil on it, just so I know that you're following along. Another box has, how do you say this number? 10 to the 3rd power. So Brooklyn, how in the world would we write 10 to the 3rd power? Mark this out and let's let Brooklyn tell us.
It would be 1 with 3 zeros.
Yes, ma'am. 1 with 3 zeros. 1,000. So the other box has 1,000 sheets of paper. Now we're to the word what, because now we're gonna have to figure out what to do. And there's a key word in this sentence that's gonna tell us exactly what to do. So here I go. What is the total number of sheets in both boxes? I heard a word that's screaming in my head that tells me exactly what to do. It's a math word. You think you heard it, Luke? What's that word?
Total.
You are so right. So let's put a circle around that total word. And Luke, what does total mean to do?
It means find the total numbers of both of them.
It means to do what, though? You still haven't told me what total means.
To add.
Add. So put a big old plus sign on that. So Kiara, what am I adding?
We're going to add 1,000 plus 300.
Which would be what?
1,300.
Yes, ma'am. 1,300. See how I did that? I look for keywords. Total always means add. Always, always, always. Number 18. A post is put every 6 feet along a fence around a, what kind of shape does this say right here? Rectangular field that's 42 foot long and 36 foot wide. How many posts are needed? So I think on your scrap paper, let's draw that field. It doesn't have to be perfect because I can tell mine's already kind of crooked, but at least it's a rectangle. Now, y'all know what a post is. It's like when you go, you know, you use this drill and you, what does it do? Like squeeze some dirt
Yeah.
and you pick it up and you pick it up. and then you put a post in, and you put like some cement or concrete,
Yeah.
and then you go, how many feet? What does it say? 6 more feet. And then you do it again. Y'all know what I'm talking about? And then what do you connect from that post to this post? Some kind of wire, isn't it, to keep your animals in. Okay, so here's the first thing that I need you to see in your head, that every 6 feet, you're gonna put a post. Are you with me? And how long is this field? What does it say? A rectangular field that is
42
foot long. So come over to your scrap paper on your field. Where would I put 42? Would I put 42 here? Would I put 42 here? Would I put 42 here? Or would I put 42 here? I gotta figure out where the long side is. You think you know? Is this the length? Actually, this is the width. You can even tell how this is a longer side than this. So this is the length. Put 42 foot right here. Well, what should I put up here then?
42.
Why would I put 42 up there?
Because they're the same length.
It's the exact same length. So if it's 42 on bottom, it's 42 on top. Now come over in your problem and mark that out. We took care of that information. We don't need that anymore. It was 42 foot long. How wide was it? Does it say right here? Just say it.
36.
So do I put 36 on the left side or do I put 36 on the right side? Just say it.
Both.
Both. Good. 36 foot here. 36 foot here. Okay. So like this, I'm going to be right here, kind of pretending like this is my field. Eyes up here. I'm going to put my first post right here. And how many feet am I going to go before I put another post? 6. And 6 more, and 6 more, and 6 more. And the whole length is 42 foot. So in my mind, if I hear 6 and I hear 42, a number is screaming in my head because 6 times something is 42. What would that
How
be?
many?
Huh?
How many? No, multiplication.
What? But what number?
7.
7. You're exactly right. Because 6 times 7 is 42. So that means 7 posts are going to go right there along the bottom. That's why you got to know your multiplication facts. So if this bottom part has 7 posts, how many posts do you think are going to go up here on the top? 7. Because it's got to go all the way around. You know what some of y'all would have done? Because I know how 5th graders think. Y'all would have figured out this, and y'all would have figured out this, and y'all would have added those two together and stopped. But guess what's going to happen to all your animals? They're going to run away because you don't have posts all the way around the field. You understand what I mean? You got to have post, 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 post all the way around the field. Some of y'all just do like this part and this part, and you stop. What's going to happen to your cows? They're going to run to drum right, aren't they? Because you didn't put posts all the way around your field. Let's come over here on this side. If every 6 feet I put a post, 6 times something is 36. What is that, class? 6. So put 6 posts here. Am I done?
No.
We're out. Why?
You have to do the other side.
You're exactly right. So I took care of this information. Now we're to the question. How many posts do I need? Cooper, help me. I gotta go to the store and buy some posts. How many did I end up needing? What am I gonna do?
Add
Add what?
7 plus 7.
Okay, when you get 7 and 7, what do y'all, when you add those together, what do you get, class?
14.
Okay, write that on your scrap paper. Am I done?
No.
No, because my sheep would go out the sides, wouldn't they? I gotta put them on, I gotta add these two. What are these, what would 6 and 6 be, class?
12.
That's 12. Now, add that together and we'll see what Hope gets. What'd you get?
26.
Well, I wanted Hope to tell me.
Oh, sorry. 27.
No, it was 26. 26 posts. 14 and 12 is 26. 4 and 2 is 6, not 7. Okay, number 19. A company had 9 times 10 to the 6th power dollars in sales last week. Let's just start right here. I don't want 9 times 10 to the 6th power. I want a real number, Colin. So let's work with this first, okay? How would we do 10 to the 6th power, Colin?
We would put a 1 and add
On scrap paper, do what Colin's telling you. Put a 1 and do what?
and add 6 zeros.
Yes, sir. 1, 2, 3, 4, 5, 6. That's exactly what we would do first.
And then we put a comma.
We would put 1, 2, 3, comma, 1, 2, 3, comma. That's exactly what we would do. What number is that, Colin?
1 million.
1 million, but we're not done because we've only done this part of it, Colin. Put your hand down for a minute. We got to multiply that times 9, Colin.
1 million times 9 equals
9
9 million.
million. So look what I'm going to do with that 1. I'm just going to turn it into a 9.
Oh, yeah.
And I'm going to put a dollar sign right there.
Oh,
Because this is money. It said dollars. Who wants $9 million? I'll take it. Okay, so here's what we have to do. We have to explain how to find the product. And what was product yesterday? It should be on your notes. Did we write it on your notes? What did we say product was?
X product is an answer to multiplication.
Answer to multiplication. How did we find the answer to this problem? What did Colin tell us to do? Let's talk it through. Okay, Bentley, what's the first thing that Colin told us to do?
Write it on scrap piece of paper. and
Write what?
1 million.
How do we get to 1 million? Keeper?
Because we write a 1. And
Okay, so here's what we did. We turned 10 to the 6th power into, now Keeper, tell me what we did.
we put a 1
A 1
and
with
6 zeros.
6 zeros. And look, Ms. Caulfield did capitalize the beginning and she put a period at the end. You have to write this too. We turned 10 to the 6th power into a 1 with 6 zeros. You need a period. This is a real sentence. Okay, Eric, is that all we did? What do we do after that?
Multiply
By what?
by 9.
Yes. Then we multiplied by 9. And look, I capitalized and I put a period again. Okay, number 20. An aquarium, that's the aquarium. Oh, no, it's not. Has the same shape as the solid figure shown below, but that could look like an aquarium. Y'all know what an aquarium is, don't you? It's got like all these fish and crabs and stuff in it. And it's got, you know, all these leaves and I don't know, that kind of stuff. So an aquarium looks just like this. Here's the question. Get your pencil on the word what. Read it with me. What is the name of this solid figure? Well, let's see. Brooklyn, what shape is just this front right here?
A rectangle.
Jake Lee, what about this back side? What shape is that? If the front's a rectangle, the back has to be a rectangle too. Now, I agree that these are squares, but squares and rectangles can be the same thing. I know that's confusing, but trust me. Rectangle, rectangle. The top is a rectangle, the bottom is a rectangle, but this isn't flat. This would be a flat rectangle, don't you agree? Could you put fish in this?
No.
Could you put little miniature trees and stuff in this?
No.
Could you put water in this?
No.
This is just a 2D figure. What kind of figure is this?
3D.
3D. It's got height, doesn't it? You could actually put water in it. So don't call this just a rectangular. This is something else. It's a rectangular, who knows? Do you know?
Prism.
Yes, rectangular prism. There's your answer. That's something y'all learned in 4th grade. Or you should have. Rectangular prism. The prism is what makes it 3D. Rectangular prism. Rectangular prism. Okay, 21. Isaac, this is about you. Isaac takes 5 minutes to ride his bike down the hill to school, and then 10 minutes to ride up the hill from school. He attends school Monday through Friday. How many minutes does he spend biking to and from school in 2 weeks? Write an equation to model your work. Well, I think the first thing we do is got to draw a picture. So Isaac obviously lives on a hill. Draw a picture. That's why you got scrap paper. If I put it on the board, you do it on your paper. Okay, now I'm going to go back, and you got to tell me where Isaac lives. We got to draw our map. Isaac takes 5 minutes to ride his bike down the hill to school. So where would Isaac live? At the top of the hill, wouldn't he? Isaac's house. And how long, Hope, does it say that he has to go down the hill? That it takes him to ride down the hill? It's on your paper too. You have it right in front of you. The very first sentence. 5 minutes. So to go down the hill, it takes 5 minutes. And Cooper, where's he going down the hill to?
School.
School. So school would be down here at the bottom. So far we've drawn a pretty good map. But Jake Lee, how long does it take to get up the hill after school? 10 minutes. Why does it take longer, Jake Lee, after school? It's up the hill instead of down the hill, isn't it? Okay, so I'm just stopping right here at this period. This is where I'm at, right here. I've gone down the hill, it takes me 5 minutes, and I go up the hill and it takes me 10 minutes. So I'm right here at this period. Got it? Say got it. Okay, that's where I'm stopping so far. Okay, so let's think about this. Isaac here. So on the first day of school, I want to know, Hope, how many minutes it took me to get to school and back home from school. Look at your map. It can't just be 5. 5 is just going to get me to school. I want to know how much it took me to get to school and back home from school. Say it. 15, because down took 5, back home took 10, so don't y'all agree that that's 15 minutes? And that's on the first day of school. So let's just see what happens right here. Get your pencil on the word he, or your finger on the word he. He attends school, what does this say? Monday through Friday. So how many days is that? 5. So how many miles, or how many minutes did he ride his bike on Monday? 15. How many minutes did he ride his bike on Tuesday?
15.
How many minutes did he ride his bike on Wednesday?
15.
What about Thursday?
15.
What about Friday?
15.
15. Now this is going to be tricky because I know what y'all are going to do. Y'all are wanting to think, oh, we'll just do 15 times 5. Look right here at how. Get your pencil on how. How many minutes does he spend biking to and from school in, what does this say right here? 2 weeks. Okay, somebody tell me what to do. You think you know?
It says Monday through Friday. In 2 weeks, you have to. It would be 10 minutes.
Okay.
You have to add.
Hold on, not 10 minutes.
Oh wait, no. I mean, in 2 weeks.
It'd be 10, not 10 minutes, but 10 something else. 10 what?
Days.
10 days, because the first week he went Monday, Tuesday, Wednesday, Thursday, Friday. Shake your head. The second week he went Monday, Tuesday, Wednesday, Thursday, Friday. So what would 5 and another 5 be? 10. So he did this 10 times. And how many minutes does it take just in one day? 15. So do you want to do 15 plus 15 plus 15 plus 15? You don't want to do that? What would you rather do?
15 times 10.
You are exactly right. So it wants you to write an equation. So right here, I want you to do 15 times 10 equals, and now we got to figure out how to work that out. So you might already know this, but if you don't, I'm fixing to show you a cool trick. I'm going to put 15 on top times, and I'm going to let my 0 hang off on 10. Have y'all ever seen this before?
Yes.
You have? Good, because it's a cool trick. Okay, just put your hand down and just watch me. So now all you have to do is bring that 0 straight down, just like that. Did y'all do that?
Yeah.
Okay, and now we're to the 1. Okay, watch me real quick. It's going to be 1 times 5 is going to get you what?
5.
And 1 times 1 is going to get you what? 1. So how many minutes did he write in 2 weeks? 150 minutes. There you go. I'm afraid if I just let y'all do that on your own, you would have just told me how much he did in 1 week. But it didn't say 1 week, did it? What did it say? 2 weeks. See how it's a little tricky? And see why when I got to that, I put a square around that? Okay? Got to be smart on that kind of stuff. Let's just mark out 22, just gently on your paper, just like I did. And I'm going to let you guys do 23 and 24 on your own, okay? So work on that until the bell rings, okay? Go.